Hello there. Today I will show you how to use QSWAT for hydrological modeling. QSWAT is plugin of QGIS, and if you look here, QSWAT 3 and QSWAT 3.64. QSWAT 3 is for 32 bits margin, and QSWAT 3.6 is for 64-bit version margin, so you can download appropriate version based on your margin. QSWAT may require some additional software like SWAT editor, Microsoft Windows, text editor, Notepad, and so on. So you have to install those software. SWAT editor requires Microsoft Windows, Microsoft.NET, and Adobe Acrobat Reader latest version. Installing QSWAT is very simple. You can see at the video in my channel, or you can simply follow the installation manual to install QSWAT. Okay. To run hydrological modeling using QSWAT, you have to prepare data, and you have to prepare climate data, digital elevation model, land use, land cover data, outlets data, soil data, and you may prepare also sediment data and so on. For today's exercise, here I prepared some data like climate data. When you say climate data, precipitation data, relative humidity, temperature data, wind speed, solar radiation data, and let us look at precipitation data. For example, this is precipitation data. This refers to the starting dates of the record, and so on the first date the record is 0, second 0, third 0.08, and you can look at also relative humidity. Relative humidity is in percents, and that is referred to the first date. Okay, and here also detail elevation model map is required in this format. Another land use land cover map is also required in this map, that is input. And also here I have outlets, main outlets in shape file, soil data in this format, and a lookup table for land use land cover, lookup table for soil data, user soil, and WGN user are also required to run SWAT. Okay, let's start or do this activity to run the model. This one is a QGIS. QSWAT is plugin of QGIS, so we need QGIS to run or to use QSWAT. Click here, plugin, manage, and then start plugin, and you have to check this one, QSWAT, then close, and you can see here SWAT as a plugin, and click here, then create new project. Let us create new project in this folder, and let's say exercise 1, then save. And I click here and use API, because that's what increase the speed of simulation. Save. And then let's start with delineating watershed. Click here, delineate. This elevation model is required to delineate watershed, so click here and navigate to where digital elevation model is saved. Yeah, this one is digital elevation model. can look at digital elevation model. And also stream network may be needed, actually required. If you have a predefined stream network, you can use check this one and load stream network for today's exercise. I don't have a stream network for predefined stream network for this area, so I will not check this one. And here we have to also define threshold by number of cell or area. Yeah, look at this: square kilometer, hectare, square meters, mile, arc, and feet. Use square kilometer and define the threshold. While we define the threshold, we have to consider the accuracy of our output and also the aerial coverage of the aerial coverage, because it's a matter on the simulation time. I use 20 square kilometer as a defined threshold area and create stream network. Creating stream network may take time. It depends on the area. If there is small watershed, it may create in small time. If it's large watershed or basin, this may take several seconds or several minutes, so we have to be patient for that. Well, stream network is created. You can look at stream network, and the next thing is we have to define the outlets. If we have already defined outlets, created outlets, we have to check this one, use inlet outlet shapefile. So I have also a shapefile of outlets, main outlets. So let me look at this one is outlet. And if you don't have outlets, you can draw outlets by clicking on draw outlets and click at the outlets points. Usually outlet point, main outlet point is at gauging station, river gauging station. Okay, let us select inlet outlet. Select inlet outlet, select like this and save. So one outlet is selected. This one is the outlet that we have, and we have to also see the snap threshold. Sometimes the predefined outlets may be at large distance from the stream network, so we have to consider either this specified space or snap threshold can reach at the outlet or not. Okay, then create watershed. Yeah, watershed is created, and you can look at your watershed, and if you need, you may merge some small watershed by selecting sub watershed. Click on this select watershed and click on watershed, then you can merge that watershed. Really, I don't want to merge the watershed for this case, and directly go to click OK. Yeah, watershed is created. The next procedure is what? Creating HRUs. And to create HRUs, click here, create HRUs. Then for creation of HRUs, we need land use map, soil map, and a lookup table of land use and soil map. Click here and navigate to where we save land use. This one is land use. and soil map. This one is soil map. Yeah, okay. Then make this one, use, and make this one, and make this one like this. And we can also see the boundaries of slope. Let us make like this 5. That means the slope boundaries from 0 to 5 to 5 to maximum. Let me add one more, 10. And in this case, the slope boundaries 0 to 5, 5 to 10, and 10 to maximum. Before click read, we have to go to place where we save our project exercise 1. So some data are what's saved here in exercise 1 folder. Click here, and this one is QSWAT 2012 metadatabase. Click here and enable editing, and here we have user soil. This user soil is user soil in SWAT metadatabase. Click here. So this one is user soil, and this user soil the user soil that we have may be not the same with the user soil in the SWAT database. For example, let us look at our user soil. This is our user soil. Yeah, this is our user soil. For example, when you look at a soil name, say soil A, soil B, soil C, something like that, but in SWAT meta database, there's no name soil A, soil B, soil C, or something like that. So we have to use our user soil. So let us rename this one. Old is user soil in meta database of SWAT, and click external data, new database, file, Excel, and browse to where we save our user soil. Here, this one is our user soil. Then open, then OK, then next, and we have to choose our primary key. Our primary key is objected. Then next, then finish, then close. If you look at here, we have two user soil. The user soil import, and all user soil come with SWAT. I can even delete this one. Yes, so in this case I have only one user soil, and I will use this user soil for simulation. In addition to this one, here WGN user should be also defined. I can define here in the SWAT database or import it. Let me import the WGNE Wabi, that is my WGEN user. Okay, next, then choose your primary key. The primary key is the objected, this one, then next, then finish, close, then close this one, close this one also, minimize this one, and now we can click read. So we are going to choose land use lookup table. Click here, land use lookup table, then Wabi lookup table, which is soil lookup table. So look at this, land use lookup table is Wabi land use, soil lookup table is Wabi soil. Okay, we are two steps forward. We delineate watershed, create HRUs. We can see here HRUs, and look at this. The number of HRU is 174. Number of sub-basin is 21, and you can look at the area of watershed and area of land use, soil, and slope in each watershed from this data. Okay, let's go to the next step. Edit inputs and run a SWAT model. Click here. And here SWAT soil database and SWAT parameter geodatabase. Okay, and this one is not the same, so let us remove this SWAT soil database, the default one, and replace by this one. Copy and paste and connect with the database. Connect. Yeah, database connection successful. Okay, then write input table. The first inputs is weather data, weather station data. Click here, and weather generator data. Click. Then we use this one, the one that we import to the SWAT metadata, Wabi. Here, station 1, because I only use one station for the exercise. That's why it says station count is 1. Rainfall data. We have rain gauge data, daily precipitation, or we can also use sub daily for this exercise. I will use daily one. Daily. Then click here. Then navigate to where I save climate data, precipitation. Okay. Then do the same for temperature. Open. Then wind speed. Wind. Okay. And solar radiation. Actually, I don't have solar radiation data, so I can just simply use this simulation. Check the simulation rather than checking solar gauge, and relative humidity gauge. Relative humidity. Open. Now click OK. Yeah, processing complete. Okay, then cancel this one. Next is what? Write inputs, SWAT input table. Click here, and to select all, click here on select all, then create table. Use weather database to calculate heat unit to maturity is only for US, so click now. For non-US user, then yes. Now look at it. Completed. Next one will be also completed within good time. yeah, building selected table, then okay, then cancel. And the next thing is editing SWAT input like point source discharge, inlet discharge, reservoirs, basin, watershed data like water quality data, land use updates, generator data, and so on. For this exercise, I will not use or I will not input those data. I will show you in how to use those data and input those data to the software in other tutorial. And for today's, let us jump to SWAT simulation. Click on SWAT. Then look at this. This one is starting date, and this one is ending date. So my data is in this range, and printout setting is in daily, so we can use daily printouts or yearly or monthly. Let us use monthly and make this one 2 year as proper warm-up. And here is what's version extension. I'm using 64 bits. Here the difference between 64 bits debug and 64 bits release. 64-bit debug may be good if you made some mistake. You can visualize what types of mistake you made in depth. But I prefer to use this one, 64-bit release, and set SWAT run. Yeah, finish SWAT setup. Okay, run SWAT. SWAT is scouting complete. Okay, then close this one. Close this one. Okay, then we can read SWAT output. Can read SWAT output. Click here and take output file to import to read. Let me only check this one, and this one. So we will import this file to the database. Yeah, then close. Then close. Yeah, you are almost on this last stage, visualization stage. Before starting visualization, let me take you to this folder, this exercise folder, scenarios, defaults, output. Let us look at what output and its output, and you can see those are outputs. Day 1 outputs up to the end of simulation, and the different types of outputs, so you can visualize those outputs. You can take this output to Excel and visualize them. Of course, it is not easy. Let's close this one, close, and close this one also, and let us visualize. Click visualize and click visualize. Yeah. Let us visualize reach, and let us visualize reach. Flow out, then flow out. So yeah, flow out, then add, and select this flow out in centimeter, then create, and you can see this one is flow out. And you can plot this flow out what flow out for sub-basin, for basin 1, basin 2, basin 3. Let us do for basin 1, which is this one. Okay, and variable flow out, add plot, and we select this one, plot, and let us save it. RCHH plot. Sorry, flow out. So you can look at that. This one is flow out, starting from this day to this. Good. You can also use line charts or bar chart like this and update. You can see flow out. Let us close this one and compare our flow out with the gauge data. This one is stream flow. This one is stream flow data. So let me copy this stream flow. Copy and compare with output this stream flow. Yeah, it seems good, but they still need some calibration and validation. Yeah, this is good. Let's close this one and back to QSWAT. And we can also animate. Variable. Let's animate variable. Let us animate groundwater recharge, groundwater flow. Animate groundwater. This one is groundwater flow, and you can see the animation of groundwater flow like this. Yeah, groundwater flow change timely. September groundwater flow, October groundwater, November, December groundwater flow, February, again March 2003, April, May 2003, June, July 2003. So this one is outflow, and you can visualize and export this outputs and report to the end users. Okay, thank you.